In this video, let's take a look at how to calculate a two-sample hypothesis test for unknown variance that's assumed unequaled and a two-tailed test. In this example, we're looking at the price of prescription drugs, since that's an ongoing national issue. So we're looking at a product called Zocor that's a common prescription cholesterol-reducing drug that's prescribed for people who are at risk for heart disease. So we have a table with data on Zocor prices from randomly selected pharmacies in 2 different states. And so that information's down at the bottom of your screen. We're going to determine if there is a difference in the means for all pharmacies in Colorado and Texas using an alpha value of 0.05. And we're going to assume the variances are unequal. Given this information, we're going to set up our null hypothesis that mu1 minus mu2 equals to 0. We're going to set up our alternative hypothesis that mu1 minus mu2 is not equal to 0. We know our alpha value is 0.05. And then using the information that we have below, we're going to calculate our average, our standard deviation, and our sample size for the 2 different states. So we'll start with the average from Colorado. So this is set up as the average of all of these values. So B26 to B41. So our X1 will be for Colorado. Our standard deviation will calculate as STDEV.S since it's a sample. And that will also use our values from Colorado in cells B26 through B41. And then our sample size is 16. We have 16 data points from Colorado. For Texas, we'll calculate our average as well, and that will be cells E26 through E38. We have a smaller number of samples. Our standard deviation is STDEV.S, again, since it's a sample, and we're using the same range, E26 through E38, and our sample size here is 13. So here, we're assuming that our variances are unequal, and we can also do this calculation even when our sample sizes are not the same size. We're going to calculate our degrees of freedom, and this is a lengthy calculation, so as you're setting this up, I encourage you to pause the video and make sure you have the formula correctly. There's enough spots where you can miss the parenthesis and run into an issue. So we're going to round down based off of our standard deviation for Colorado pharmacies, which is given in cell B13, that value squared, divided by B14, which is our sample size for the Colorado pharmacies, plus E13, which is our standard deviation for the Texas pharmacies squared, gives us our variance, divided by our sample size for the Texas pharmacies. This calculation is squared, and then it's divided by our B13 squared divided by B14, that value squared, divided by B14 minus 1 plus E13 squared, divided by E14, that value squared, which is also divided by E14 minus 1. And then we're going to round down to a whole number. So our degrees of freedom is 24. So quite a lengthy calculation, which is why it's great to do in Excel, because it's very easy to make a mistake. Our T calculation then is going to take B12 minus E12 divided by the square root of B13 squared divided by B14 plus E13 squared divided by E14. So we get a value of negative 0.902. Our T critical value, since we're doing two-tailed, will have 2 sides of the distribution, a positive and a negative. So we'll have T dot inverse dot two-tailed we'll use B11, which was our alpha value, and B16, which is our degrees of freedom. B19 will be the negative side, so it's negative B18. And then for our conclusion, we're looking to see if our value falls within this region. So we're setting it up to look at if it falls within those regions inside of our t calculations. If it does, we fail to reject our null hypothesis. Otherwise, we reject our null hypothesis. So our conclusion is that we fail to reject our null hypothesis, which makes sense because our value falls in this region. And then our p-value is calculated as our t.dist dot 2t, since it's two-tailed, and it's the absolute value of our t calculation and our degrees of freedom. So our p-value is 0.3761, which is considerably higher than our alpha value, so we don't have much confidence within our results. So we do still have the conclusion to fail to reject our null hypothesis, but the p-value is telling us that a difference of sample means of this magnitude would happen about 37% of the time if mu1 equals to mu2, or the average of Colorado pharmacies' price equals to the average price of Texas pharmacies. So that is a lot to do within Excel. Let me show you how now to do the calculation using the data analysis tool pack. Within the data analysis tool pack, we can calculate the output using the functions within Excel. So we'll get information on our mean, our variance, our critical values if it's two-tailed, etc. So we're going to set this up as shown in this screenshot. So we're going to go through and go to Data, Data Analysis. We're going to select the t-test to sample, assuming unequal variances, and then OK. Our variable 1 range, we will select B26 down through B41. You'll notice in this one I'm not selecting the labels because the labels are not descriptive enough. If I had information that said this was Colorado, then I'd want to select that label because it'll help with showing the output in the end. My variable 2 range will be E26 through E38. My hypothesized mean difference is 0. I did not select my labels, so I'm not checking that box. And then my alpha value is 0.05. I'm going to change my output range so that it is cell K1. Since I already have this output, I'm going to cancel out of this, but if I selected OK, I would get this output without the shading. So I've highlighted some important values. So since I did not select the header because it wasn't descriptive, I would likely want to change this to Colorado and then Texas. So I can type in these boxes so that I can have that descriptive heading. I have my t statistic, which matches what I calculated before, of negative 0.902. I have my p-value, but more importantly, I have my t-critical value. Since it's two-tailed, Excel is only going to show me one of the values. So I have to remember that two-tailed, I would have really a value of positive 2.06 and negative 2.06. And I would compare that to my t statistic. So this is why they're highlighted in green here, because they're my important values. The output will not tell me if I need to reject or fail to reject my null hypothesis, I need to compare those. So while it's a much quicker operation, I still have to make sure I interpret it correctly. So my negative 0.902 value would fall within the fail to reject region. So I would fail to reject my null hypothesis. And I would be able to look at my p-value and say that I don't have a considerable amount of confidence in my results because my p-value is fairly high. And I know that, again, 37% of the time, I would see this magnitude of difference between the pharmacies in Colorado and the pharmacies in Texas.